Okay, let's just start from number 16, the second video for review of AP Calculus AP midterm. Number 16, the graph of G prime is shown here. Which of the following statement is or are true of G at x equals a? At x equals a, this point, corner, it is continuous. This function is not gx function, G prime function. This function graph is for y equals g prime. Derivative function exists anyway at x equals a. So g is what? Differentiable. Differentiable means what? Derivative function exists. Okay, because g prime, if that function is gx function, this point is corner or cusp, and those point derivative doesn't exist. It's not differentiable, right? But this function graph is not gx, it's g prime of x. G prime of x exists at x equals a. That's why gx is differentiable because derivatives exist. That's correct. Differentiable function automatically is continuous. Yep, continuous. And then what about gx at x equals a, g prime of a is positive y value, right? So g prime of a is positive. Okay, if the derivative function is positive, original function is increasing. That's why g is what? Increasing. 1, 2, and 3, all right, all true. So E is the answer. Number 17. Function f, whose graph is shown, has f prime is 0 at. Alright, fx function is graph, right? Derivative function means what? Slope of tangent line. At x equals 2, fx has relative maximum point. At the relative maximum or a minimum point, if we find the tangent line, that line slope gonna be 0. That means derivative 0, right? So at x equals 2 only. At 5, it have corner. At corner, the function is not differentiable. That means f prime of x doesn't exist. That's why 5 is not. So 2 only is answer. A is answer. Let's go to number 18. A differentiable function f has a value shown. Estimate f prime of 1.5. F prime of 1.5. That means slope of a tangent line at x equals 1.5. But there is no 1.5 in this table. So this function graph has some function graph under the graph, but we know some specific points. Suppose at 1.4 is here, and then the y value is 14. 14 at this point, right? Suppose 1.6 is here. At 1.6, y value is 22. 22. I don't know what kind of function is that. Suppose a function like this. It's kind of curve, right? But tangent line at x equals 1.5 is impossible to find, but you can use these 2 points. These 2 points, because 1.5 is between 1.4 and 1.6. And then just find slope of this straight line between those 2 points. So y2 minus y1, 22 minus 14 over x2 minus x1, 1.6 minus 1.4. That is 8 over 0.2. So it is equal to 40. So approximation value of f prime of 1.5 is 40. So D is the answer. Number 19. The left half of the parabola defined by y equals x cubed minus 8x plus 10. So you should understand this function for x is less than or equal to 4. There's a left half. That's why x is less than or equal to 4. How can you find the vertex point x coordinate? Negative b over 2a. This is algebra 2 formula, right? Negative 8 over 2 times 1, which is 4. So where is the vertex? Vertex is at x equals to 4. and then because the leading coefficient is positive, it opens up. Okay, and then at x equals 4, I don't care where is a y value, but the graph looks like this, right? Vertex point at x equals 4. But only we consider left side of that function, right? So it is not count. Right side doesn't matter. The left side only. Okay. Find that g prime of 3 is a one-to-one function derivative of its inverse. Its inverse is also a function called that inverse function is g. Okay, what is f prime of 3? That means f prime, f inverse functions derivative, right? What's the formula? 1 over f prime of f inverse 3. Okay? How can you find f inverse of 3? Inverse function is x and y switched, right? To find the f inverse of 3, plug in 3 for y and find the x value. Okay? So plug in 3 for y. 3 equals x squared minus 8x plus 10. So x squared minus 8x plus 7 equal to 0. So x minus 1, x minus 7 equal to 0. X equals 1 over 7. 1 over 7. Okay, but x cannot be greater than 7. So x equals 1, I think, because x should be what? Less than 1 equal to 4. So 1 over f prime of 1. Okay, f prime of 1, that means what? Derivative, find the derivative function, plug in 1 for x. So what is y prime? Derivative of x equals 2x. Derivative of negative 8x and negative 8, any numbers, constant, derivative 0. And then plug in 1 for that is negative 6. Negative 6. Alright, so 1 over negative 6. So B is the answer. B is the answer. Number 20. FA is equal to FB is equal to 0. fx is a continuous function between a and b. Then, okay, fa and fb is equal to 0. So if we draw the graph, suppose this is a, this is b. The function graph has 0 at a and b. fa is 0, fb is 0. It's something like this, right? A, fx must be identically 0. No. fa is 0, fb is 0. So at x equals a, at x equals b is 0, but the other x is not 0. It must, it doesn't have to be 0. Number B, choice B, f prime of x may be different from 0 for all x on a, b. It don't have to. All different, f prime of x means slope of a tangent line. Okay, so for some x values, you can have same derivative, same slope, because that function shape kind of varies. So it must have, it don't have to be all different. C, there exists at least one number. C is between a and b. Something like this, right? Something like this. At this point, its slope is 0, f prime. If there's a c, f prime of c is 0. C is between a and b, right? Is a possible answer. Okay, I don't say this is answer yet. D, f prime of x must exist for every x on a, b. I don't know. What about this kind of case? I give you some different case. If the function looks like this, yep, it is continuous. Yes, it is a continuous function. But what about at x equals c? f prime of c is 0? No. It's cusp. So derivative doesn't exist, right? That makes sense, right? So there is no any point derivative is equal to 0. So it is not always true. And the f prime of x must exist for all every single point. No, at x or c, derivative doesn't exist. Okay? So what is the final answer? Actually, none of the preceding is true. Okay? The E is the actual answer. Continuous doesn't mean differentiable. If fx differentiable, the fx is automatically continuous, but all continuous functions are not differentiable. That's why. Answer is E. Number 21. Number 21. The slope of the curve y cubed minus xy squared is equal to 4 at the point where y equals 2. Find the slope at y equals 2. So I want to find the y equals 2 and then find x. Plug in 2 for y. 2 cubed minus x times 2 squared is equal to 4. So 8 minus 4x equal to 4. So x equals 1. So y is 2. That means x equals 1. And then find the derivative at 1, 2. X equals 1, y. You can do implicit differentiation. So how can you find the dy over dx for this function? Derivative of y cubed, 3y squared, then dy minus. It is a product rule. So u part is x, v part is y squared. U prime v, 1 times y squared. So 1 came from x function, that is dx. And then minus x times 2y, and then dy is equal to 0. 0. I want to find the dy over dx from this equation. All right? There are two dy terms. I gather together dy terms. 3y squared and negative 2xy dy is equal to y squared dx. So dy over dx is equal to y squared over 3y squared minus 2xy. And then plug in 1 and 2 for x and y. So y is 2. 2 squared is 4 over 3 times 4, 12. Minus 2 times 1 times 2, 4. It is 1 over 2. So D is the answer. D is the answer. Number 22. Number 22. The equation of a tangent to the curve y equals x sine x at the point pi over 2 pi over 2. Okay, equation of a tangent line. If x is, the point is already given, x value pi over 2, y value pi over 2, right? So we need just what? Slope. Slope is derivative. So y prime is what? By the product rule, u prime 1 times sine x plus u v prime x times cosine x, because sine x derivative is cosine x. And plug in pi over 2 for x. Okay, 1 times sine pi over 2, sine 90 degree, that is 1. So 1 times 1 plus pi over 2 times cosine pi over 2 is 0. So slope is 1. So y minus y2 is equal to slope m times x minus x2. So answer is what? Y equals x. This cross out. Y equals x. E is the answer. Number 23. Minimum variable function of this. Minimum variable function. So what about, what is the function graph? Actually, that's y equals -4 square root 2 minus x graph. Do you know this function, radical function graph looks like this. Y equals negative root 2 negative x function graph, right? Domain is less than or equal to 0, and range is less than or equal to 0. And then it is translated 2 unit to the right, and then 4 is what? It's a vertically stretched fold by 4 unit, right? So that graph is just translated to 2 unit to the right, and anyway this direction, this type of graph, right? This point is 2. So what is the minimum value of the function? This point, the maximum value, I mean, this point the highest point, right? This point the highest point. So actual maximum value is 0 at x equals 2. Okay? If x is 2, y value is 0. But all for the other x less than or equal to 2, the domain of this function is less than or equal to 2, right? Negative 4 times radical any number is negative number, right? There's no any positive number. It's kind of a common sense, okay? You can use algebra knowledge for this problem. Number 23, answer is A. Number 24, for which curve shows below both f prime and second derivative is negative. First derivative is negative, and then second derivative is negative. By the first and second derivative test, if first derivative function is less than 0, the original function decreasing, and then if second derivative less than 0, concave down, decreasing concave down, possible decreasing concave down graph is this kind of, right? So only possible is E. Decreasing concave down, only E is possible function graph. Okay, number 25 to 27, the position function s of t is given. Okay, the particle is at rest. At rest means velocity gonna be 0. So position functions derivative is velocity function, and velocity function's derivative is acceleration function. So just find that velocity function, which is derivative of the given position function. T to the fourth, derivative 4t cubed, and then negative 6t cubed, derivative negative 18, 6 times 3 is 18, t squared, and then 24t. That equal to 0, right? So what is a common factor of these three terms? 2t, and 2t squared minus 9t plus 12. What is the 0 of this function? Just t equals 0, right? What about this part? Negative 9 squared minus 4 ac. Discriminant is less than 0. That means the quadratic function has no any real solution. So only when t equals 0, the particle is at the rest. That means derivative is 0. I mean, velocity is 0. So B is the answer. Okay, next problem number 26. What velocity? The velocity v is increasing when? Increasing when? Okay, velocity is increasing. That means acceleration is positive. Velocity is increasing. That doesn't mean velocity is positive, right? Okay, so acceleration is positive. That means velocity is increasing. So second derivative of position function is acceleration. So acceleration function is equal to 12t squared minus 36t plus 24. And then I can factor this. 12t squared minus 3t plus 2, so t minus 1, t minus 2. So 0 of this function 1 and 2 in the graph, AT graph, at 1 and 2, acceleration 0. And then the graph looks like this. Okay, So v is increasing, positive acceleration, this part and this part. When t is less than 1, between 0 and 1, and then t is greater than 2. Less than 1, greater than 2. Automatically is greater than 0, right? So D is the answer. Number 27, speed. Okay, speed is particle is increasing. Speed is absolute value of velocity is speed. So you need to find the absolute value of velocity function. So speed function is equal to absolute value of 4t cubed, 18t squared, 24t. Okay? And then think about velocity is always positive, right? We told when t equals 0, that velocity was 0. If t is greater than 1, like greater than 0, like 1, or 2, 3, 4, 5, that is always positive. Do you know absolute value of a function? How can I draw the absolute value function graph? Any part of under the x-axis, if the graph is at velocity, this part is flipped across the x-axis. So this is speed function, right? But velocity function is always positive. So there is no part under the x-axis, right? That means velocity function is equal to speed function. Okay? So speed is increasing. So 0 to 1 and 2. Same thing. So speed function increasing, in this case velocity function increasing. Same question basically. But some part of velocity function is under the x-axis. You have to flip over that part. In that case, the answer is going to be different. Okay, number 28. Best linear approximation, fx equals tangent x near x equals to pi over 2. So y equal tangent x, right? I'm going to do implicit differentiation. So derivative of y is what? 1 times dy equals tangent x derivative secant square x times dx. Okay. So what is dy? That's the question. What is dy? Okay. If x is pi over 4, what is f of pi over 4? Tangent pi over 4. That is 1. So y value is 1. So approximation value is what? Y value plus dy. Change of y. So you can find the dy from this equation, right? So what is the secant square of pi over 4? Secant is 1 over cosine. So 1 over cosine pi over 4. That's secant pi over 4. It is 1 over root 2 over 2. That is root 2. So it is 2. dy equals 2 times dx. What is dx? X difference. X minus pi over 4. That's why our answer should be 1 plus dy, 1 plus 2 times x minus pi over 4. 1 plus 2 times, D is the answer. Next problem. Number 29 to 32. Time and velocity function is given. This is time in second, velocity feet per second is given, 0 to 5. Number 29, the object attains its maximum speed. So draw the speed function. It is 3, negative 10. So 3, 10, connect these points and then this point. This red color graph is what? Speed function, because speed is absolute value of velocity. Any part of under the x-axis, we flip over the x-axis. So t equals 3. At t equals 3, maximum speed is 10. So D is the answer. Number 30. Speed of an object is increasing during time. Speed is increasing. So where? This part, speed is increasing, right? The red color is speed function, the 2 to 3, right? 2 to 3. So D is the answer. D is the answer. What about number 31? Acceleration of object is positive. It's positive acceleration. Positive acceleration, what does it mean? Velocity function is increasing. Velocity function is increasing. So given function graph is a velocity function, right? When the velocity function is increasing, it here, right? 3 seconds to 5 seconds. So positive acceleration means velocity is increasing at 3 to 5. Number 32, during 2 seconds to 3 seconds, 2 to 3, what acceleration? 2 to 3. 2 to 3, acceleration is derivative of velocity function is acceleration. That means slope is acceleration, slope of velocity function. Just find the slope of this line, y2 minus y1 is from this point to this point, rise over 1, so negative 10 over 1. Right? So negative 10 feet per second square. Negative 10 is the answer. Last problem, number 33. Okay. F prime of x is graph in the estimate what is fx graph, right? Just could be fx graph. What about between 0 and 1? Between 0 and 1. Okay. The f prime of x graph is above the x-axis. That means the forced derivative function is positive. And then that forced derivative function graph is decreasing, which means second derivative is negative. If forced derivative is positive and second derivative is negative, for the original function graph, increasing concave down, right? Increasing concave down. So this kind of shape, this kind of shape. What about between 1 and 2 in this section? The derivative function graph is below the x-axis. That's why forced derivative is less than 0. And then it is still decreasing, so second derivative is less than 0. For the original function, if forced derivative is less than 0, that means decreasing. And then second derivative less than 0, concave down. Decreasing, concave down. Right? What about when x equals greater than 2? Forced derivative function graph is under the x-axis, forced derivative less than 0. But it's increasing, so second derivative is positive. So forced is negative, second is positive. For the original function, decreasing concave up. So graph shape gonna be like this. Okay. This point is 1, 2, 3. So which one is possible answer? Yep, C is the only possible function graph. C. I solve all 33 problems. Okay, so I really hope that this video can help your midterm of AP Calculus AP next week. Okay, I'm done. Thank you for watching my video. Bye-bye.